Okay, so in this question here, 37 from the textbook, we have to solve the system of three equations. So there's three variables. There could be one solution, there could be infinite, there could be no solutions. So that's because it's a square system, meaning the same number of variables as equations. So we can eliminate x, y, or z. Looking at the coefficients, I think x is going to be the easiest case because we have nice coefficients. Like 1, I could double that and get 2, and triple that and get 3. Whereas, like, I would have to take this 2y and multiply everything by 9 to get an 18y, and then multiply everything here by 2 to get a negative 18y. And then this number gets really big, and like 7 and 36, like 7 isn't a multiple of 36. So you want to look for that coefficient of 1, which I guess you have with y and z as well. So like it really doesn't matter which variable you eliminate. Just 1, 2, and 3 seem the easiest to work with. So I'm going to eliminate x because, again, these are nice coefficients here. Alright, so first I'm going to take negative 2 times the first equation and add it to the second equation. Alright, so that would eliminate my x's. I would get negative 2x plus 2x. Alright, then if I multiply 2y by negative 2, I get negative 4y. And then plus y gives me a negative 3y. And then if I multiply this top term by negative 2, I get 14z. Plus z would be 15z. And then if I do negative 4 times negative 2, that's 8. Plus 13, that would be 21. Alright, so now I have one equation in terms of just y and z. Alright, so now I'm going to do the same thing, but eliminate x by using equations 1 and 3. So now I could take negative 3 times equation 1 and add it to equation 3. So this would be like a negative 3x plus 3x, that would cancel out. And then this would be a negative 6y plus 9y, would give me a 3y. And then a negative 3 times negative 7 would give me a 21z, plus negative 36z gives me negative 15z. Alright, and right now I'm noticing that, like, I got negative 3y and 15z and 3y and negative 15z in the second equation. That's telling me I'm probably going to have either infinite or no solutions, because both variables are going to cancel when I go to eliminate y and z. Alright, but when I do negative 3 times negative 4, that gives me 12, plus negative 33, and that gives me negative 21. Alright, so this seems to have infinite solutions. How do I know? Well, I just went to eliminate x, and that is how you approach all these problems. So I got 3 equations with 3 variables down to 2 equations with 2 variables. Alright, now when I go to eliminate y, which I could do by just adding these equations because they already have opposite coefficients, alright, z also eliminates. So I get 0 on the left side, and then 21 plus negative 21 gives me 0 on the right side. 0 equals 0, so that tells me there's infinite solutions. Alright, so now I have to express these solutions in terms of x, y, or z.